as the question says, a block of mass m is placed on a triangular block of mass m, which in turn is placed on a horizontal surface as shown in figure. Assuming frictionless surface, find the velocity of the triangular block when the smaller block reaches the bottom end. So this block is here. When it reaches this point, we need to find the velocity of this mass capital M. Now friends, let us suppose that this small m mass is having an acceleration of a1 with respect to ground to the right. Then this will be having some acceleration to the left, a2, because we will having the external force to be 0, which means that acceleration of center of mass has to be 0. Now friends, also let me take the acceleration a downward along this wedge with respect to ground. Now I can say that the acceleration along the wedge of small m with respect to capital M is g sine alpha, as it always is. It's coming down the wedge, so it's gonna be g sine alpha with respect to that wedge. Also, a1 is the horizontal component, so I can say that a1 is basically g sine alpha cos alpha, and moreover I can write that mass into a1 minus a2 is equals to ma2. Basically, what I said was that acceleration of center of mass has to be 0. Then this is the acceleration of this small m to the right, while this is to the left. This a1 is basically the component, horizontal component of this acceleration am with respect to m. So this is with respect to ground in the horizontal direction, and so it is from this, because acceleration of center of mass is 0. From this we come to know that a2 is mg sine alpha cos alpha upon m plus m. Let me mark as equation number 1. Now we have found out the acceleration of this block capital M, but we need to find the velocity v after some time. And what's that time? That time is when this block comes to this ground, to the bottom level. So let me find that time, and then I'll put in the equation to get what its velocity is. So friends, for that, applying for this small m block, I know that S equals to ut plus half at square. And thus I can write it as h by sine alpha, which is the length of hypotenuse of this wedge, is equals to half a t square. So time comes out to be 2h upon a sine alpha. Now a is actually the acceleration along the wedge in downward direction with respect to ground. So what's a? A is basically g sine alpha, that is with respect to this wedge in downward direction, then a2 cos alpha. Because a2 is this, so cos alpha, it will be here. So a minus b2 cos alpha gives me the g sine alpha minus a2 cos alpha gives me the acceleration a. Now I can employ the first equation of motion for this capital M block, that is v equals to u plus at. Putting the values, we get v equals to a2t, and so we get the velocity to be 2m square gh cos square alpha upon m plus m into m plus m sine square alpha whole to the power half. So this is actually the velocity of the triangular block when the smaller block reaches the bottom end.